Hello, myself Prathmesh from the B4 batch. My roll number is 820. The title of the research paper which has been chosen by me is the security analysis of MySQL's encryption function. This research paper has been published by the IEEE in the year 2015. The author of this research paper is Lijun Zhang, Ziafan, and Yuzo. Here, let's start with a short introduction about the MySQL and the need of security in MySQL. MySQL is the most popular database with open source that is developed and supported by Oracle Corporation. This is because of its speediness, reliability, and easy configuration. As you know, where comes the data storage, on the other end, there comes the security. Nowadays, the security of data storage is of great concern and draws user attention increasingly. MySQL takes advantage of privileged system to grant various operation privileges for authenticated users and encryption functions in order to provide security of password or other sensitive data. Let us understand this through an example. If the password of database administrator is leaked, then anyone can operate as an administrator with all top privileges, which could be quite dangerous. So encryption functions play an essential role in concrete security realization of MySQL. Problem statement. The motivation of this research paper is to analyze encryption functions in MySQL carefully so as to evaluate the real security and propose a remedy solution for vulnerability being found. In this paper, we will investigate the inner principle and security of encryption functions in three main categories and indicate that most of them are not secure as MySQL has claimed in the official manual document. Literature survey required for the security analysis of the MySQL encryption functions is as follows. The popular database MySQL provides many cryptographic encryption functions in order to protect the privacy of its data storage. Description in the latest official document of MySQL claims this encryption functions provide sufficient security strength for password and data storage, but that is not always the case after a detailed analysis through this research paper. In this paper, we will divide this function in three categories, which are the password-related encryption function, the message encryption function, and hash function. The first category is the password-related encryption function. As we know, password is the essential authentication proof for a user when accessing to a database. Generally, the database will not store the plain text of password, but it will store the hash value of it. There are totally three available hash functions for the storage of the user's encrypted password in the latest MySQL version, which are named as old underscore password, password, and SHA-256 underscore hash respectively. Now we will analyze these three functions turn by turn. The inner encryption principle of this available three hash function is as follows. Old underscore password is the original hash function used in previous 4.1 version. This function is very simple, whose output value is just the concatenation of two constants transformed by user's password. For example, the hash value of test and TE whitespace ST is the same, which is as displayed. After version 4.1, MySQL provides another function password which takes the popular cryptographic algorithm named as SHA-1 as its core component in order to acquire more secure authentication. For example, password test is as displayed starting with an asterisk symbol, while password TE whitespace ST is as displayed starting with an asterisk symbol. From version 5.6.6, MySQL provides the third password encryption function SHA-256 underscore hash. The highlight of this new function is that it introduced the stored a random value to make the result non-deterministic. Now, the security analysis of this available hash function is as follows. For old underscore password, the length of output value is of 8 bytes actually. Moreover, we find that the ciphertext of password can be divided into two parts with each of 4 bytes. Since the output is just a concatenation of two strings which is of integer type, the former 4 bytes are independent of the latter 4 bytes. So the attacker can attempt the password only by computing the former 4 bytes and checking whether the result is correct or not. For password hash function, one weakness is that it does not adopt a salt value as an input parameter, which means for every certain user password, its corresponding output is determinate. The other weakness is that there are only 2 times of the computation of the SHA-1 algorithm in this function. So attackers could pre-compute a table composed of pairs of password ciphertext without consuming much time and effort. SHA-256 underscore hash function has eliminated all this weakness and can be regarded as a secured password encryption function at present. SHA-256 underscore hash is the secured from among the 3 hash functions. The next category is the message encryption function. There are mainly two pairs of message encryption and decryption function, which are named as AES underscore encrypt or AES underscore decrypt and encode or decode. There are two main weaknesses of both AES encryption and decryption function. One is that the correctness of user's key can be rapidly determined without decrypting the whole message, since it adopts ECB encryption mode and the last byte is enough to judge the key's correctness. The other weakness is that if the length of user key is small than 16, which is the usual case, then this key will be directly applied as AES encryption key, which loses the necessary randomness. So, as an attacker can efficiently implement the brute force attack to recover the user key. The last category is the hash category function. MySQL also provides several kinds of hash functions such as encrypt function, MD5 and SHA category with optional output length of 224, 256, 384 and 512 bits. Encrypt is a hash-like function which accepts input of any length and returns a result of length 30. The particular characteristic of this function is that it actually only takes the first 8 characters of input as valid. The rest part will be ignored directly. For example, all the result of encrypt P4SSW0RD or encrypt P4SSW0RD appended with 1 and an encrypt function as P4SSW0RD appended 1, 2, 3 are as displayed. For MD4 and SHA category, the input parameter is only the plain text without a salt value, which induces the vulnerability to rainbow attack or dictionary attack. Here, we completed with the security analysis of the MySQL encryption functions. The conclusion of this research paper is that we have studied about the security of 3 categories of encryption functions in MySQL. We illustrated their inner encryption principle. Moreover, we also analyzed the vulnerability of the security with concrete instances and presented the corresponding attack. Future scope or the suggestion to enhance the security of MySQL data storage is as follows. Choose an acknowledged secure cryptographic algorithm and operation mode to encrypt message. Implement a secure hash function to store and verify the password. It is necessary to compute the hash value of user's password with enough long salt, which will frustrate the pre-image recovery attack and rainbow attack. A piece of suggestion for all the MySQL users is to set a strong password excluding the weak passwords such as 1, 2, 3, 4, 5, 6, 7, 8, birthdays, English words, etc. Complicated password can be very helpful to resist social engineering attacks. Bibliography or the references which are required to build this research paper is as follows. Here we come to an end of this research paper. Thank you.